All right, we're going to solve this word math problem, and the rules for word math are quite simple. What you have here is a long division problem. The letters are substituted for numbers. Determine the value for each letter, then arrange the letters in order from 0 to 9, and they will spell a word or phrase. In this particular problem, we have the word inmate being divided by neat, and it gives us the answer ape with a remainder of EHI. Of course, that doesn't look like a whole lot because, again, we're looking at letters instead of numbers. The object, again, is to find out what each of those letters represents as far as numbers. All right, so the first thing that you want to do when you're working one of these word math problems is that you have to isolate several other math equations that are within this long division problem. And you've got three subtraction problems. The first subtraction problem is right here. INMA minus TAUE equals HMP. Don't worry about this because the T will come down. Anyway, I've isolated that particular subtraction problem here. The next subtraction problem is HMPT minus HUAI equals ETC, and that's that one here. And I did the same for the third subtraction problem here. Now there are also three multiplication problems, because once you have a number up here, you're going to take this number, this 4-digit number, multiply it by that single digit to arrive at this answer here. So you've got neat times A equals TAUE, which I've transposed down here. Second multiplication problem, neat times P equals HUAI, and so forth. And then the third one, neat times E equals EHMP, which we have down here. All right, so for the time being, we can set our master sheet off to the side and take a look at these problems here. Now, I've already gone through and solved this, but when you're solving it, you're going to find someplace in one of these equations a hint, a clue to get you to the first number that you're going to need to go on and then solve the rest of the puzzle. Well, after analyzing this for some time, one of the things that kind of stuck out to me eventually was this thousands column in the first subtraction problem. We have I minus T equaling nothing down here. Well, if it was I minus I or T minus T, this would make a lot of sense. But we have a different letter on the top from the bottom. So what does that tell us about these two variables? Well, I is going to have to be 1 greater than T, because what eventually happens here is that we're going to borrow from this thousands column over here, and that'll make this number at the top the same as the bottom number here, which is why we get nothing down here. So we don't know what the numbers are. I could be 5 and T 4, it could be 8 and 7. We don't know, but what we do know is that I is 1 greater than T. What can we do with this information? Moving on to our next sheet. I've started this grid, this table over here, where I've got the letter T and the numbers 1 through 8. T will not be 0, because if it were 0, you wouldn't have anything here. It would just be blank, much like it is here. Same thing with the letter I. I've got the value for I, 1 greater than T. T equals 1, I equals 2, T equals 2, I equals 3, and so on. So we have the numbers 2 through 9, but no 0 down at the bottom. These are our possibilities for those two variables. Why do I have the letter P in the middle? Well, because the next thing I found was that in this second multiplication problem, very conveniently, T and I happen to be in this ones column here of this multiplication problem. We have T times P equals I. Well, how does that help us? Follow along and it will become clear as we go. For example, if T equals 1, I would have to equal 2. Is there any number that we can multiply times 1 to give us 2? Of course, 2. However, you cannot have the same number represented by 2 letters. 2 and 2 won't work here. So we can cross that possibility off of our sheet. Let's move on and try 2 at the top and 3 at the bottom. Now, why will that not work? Well, because anything that you multiply by 2 is also going to have to give you an even number at the bottom. And this, since this is a 3, we know that that won't work. We can eliminate that as a possibility. Let's move on and make T3 I4 and see if there are any possibilities there for P. 3 times 1 would be 3, 3 times 2 would be 6, 3 times 3 won't work. Can use the same number. 3 times 4 would be 12, 3 times 5 would be 15, 3 times 6 would be 18, 3 times 7 would be 21. However, 3 times 8 would give us 24. 3 times 8 would give us 4 here, carry 2 to the next column. Let's put P equals 8 in that particular situation. 3 times 9 would give us 27, so the only possibility, if T is 3 and I is 4, P would have to be 8. Now we go back and put 4 for T, 5 for I, and we have run into the same problem that we had for 2, which is any even number at the top, regardless of what you multiply it by, is going to also have to give us an even number or a 0 down at the bottom. So we can eliminate actually 4, 5, 6, 7, and 8, 9 because of that even number situation there. That leaves us with 2 more possibilities where T equals 5, I equals 6. That won't work. Why? Because anything that we multiply by 5 is going to give us either a 0 or a 5 at the bottom. 5, 10, 15, 20. We know that that won't work. We can eliminate 5, 6. Let's try and see if 7, 8 will work. 7 at the top, 8 at the bottom. 7 times 1 would be 7. 7 times 2, 14. 7 times 3, 21. 7 times 4 would give us 28. 7 times 4 would give us 28. Carry 2. Let's put 4 on in our chart here on our grid. Would anything else work? 7 times 5? No. 7 times 6 would be 42. 7 times 7, you cannot use the same number. 7 times 8 would be 56. 7 times 9 would be 63. So, if T is 7 and I is 8, P would have to be 4 and only 4. Now we've got this down to 2 possibilities. Where can we take that information up on one of these problems and work that? We'll look very carefully here, and you'll see that we also have another multiplication problem with T at the top, P at the bottom. T and P. Now we can try to solve for E. Let's add E to our grid. And let's try this first set of numbers. If T is 3, it's telling us that P would have to be 8. Is there any number that we can multiply times 3 to give us 8 in this ones column? 3 times 1 is 3. 3 times 2 is 6. 3 times 3 will not work. 3 times 4 would be 12. 3 times 5 would be 15. But 3 times 6 would give us 18. So we could put 8 over here for E. Excuse me, that would be E equals 6, not 8. Because 3 times 6 gives us the 18. 3 times 7 would be 21. 3 times 8 would be 24. 3 times 9 would be 27. So if we have T equaling 3, P equaling 8, E would have to be 6. Let's try that with our other set of variables, where T equals 7 and P equals 4. Is there a number for E that we can use? 7 times 1 would be 7. 7 times 2, right there. 7 times 2 would give us 14, carry 1. Let's put 2 for E in that particular scenario. 7 times 3, 21. 7 times 4, 28. 7 times 5, 35. 7 times 6, 42. 7 times 7, no good. 7 times 8, 56. 7 times 9, 63. So, we still have 2 particular sets of variables that could still work in the problem. Now we have to take this information and use it in one of our other problems. Again, after analysis, this is really the breakthrough point of the puzzle, because we have E, P, and I neatly stacked in the ones column of our third subtraction problem. Let's try this first set of variables and see if it will hold true. If E is 6, P is 8, and I is 3, Is there any way that that will work? Well, clearly 6 is less than 8. We're going to have to borrow from the tens column and make that 16. 16 minus 8 is also going to give us 8 at the bottom. That will not work. Now, as we go to the second set of variables, we have to hope we have to hope that that's the one that's going to work, because that's the last set of variables that we have to work with, where we have e equals 2, p equals 4, I equals 8. Is that a possibility? Well, once again, we have 2 less than 4. We're going to have to borrow from the tens column, making that 12. It doesn't matter what C is. We're going to borrow, even if it's 0, we would borrow from the hundreds all the way over. But 12 minus 4, in fact, will give us 8 at the bottom. 12 minus 4 is 8. This is our key. This is the breakthrough, and we can now take those first 4 numbers and substitute them in all of our other equations, and we'll move forward from there. So every place that I have a t, I have to put a 7. So bear with me here. Seven. We do have a 7 there as well. I'm very prone to not getting all of the numbers where they need to be. But bear with me and we'll see if we can do this correctly here. P would then have to be 4. Let's go ahead and put 4 every place that we see P. Double check to make sure I got all of the P's. I believe I did. Next, we're going to put 8 for I. 8, any place that we see an I. And I believe that is all of the I's. I will double check that. And finally, we need to put 2 every place that we see E. There are a lot of E's here, so we're going to fill in a great portion of the puzzle. All right, and let's see here. Make sure I didn't miss anything there. I believe I have all of the T's, P's, I's, and A's. All right. Now, with those numbers filled in, where can we go next? The first thing that I see here is the ones column of our second subtraction problem. We have 7 on the top, 8 on the bottom. We're going to clearly borrow from this 4 to make that a 17. 17 minus 8 is going to give us 9 down at the bottom. C equals 9. And we can start filling those in. Looks like there's only 2 places for C there. All right. Now, since we borrowed from that 4, it makes that 3 instead of 4 because we borrowed 1. What are we going to be able to subtract from that 3 to give us 7 down at the bottom? Well, clearly we're going to borrow from something over here because you cannot use 2 or 1 or 0 down there. That won't give us 7. What we're going to have to do is we're going to have to borrow, make that 13, and that's going to make that A 6. Because 13 minus 6 will give us 7. A then equals 6. Let's go ahead and put 6 in every place that we have A. We've got all kinds of possibilities here now. Let's go back down to this. Third multiplication problem. At this point, you can kind of jump around wherever you see places to start filling things in. We've got 7. 2 times 7 is that 14. We carried the 1. 2 times 6 is 12 plus the 1 is going to make this 13. Carry 1. So now M equals 3. We can start filling in the m's. Are there any others? I don't believe so. We do not know yet what n is, but where else can we go at this point? Let's try this second multiplication problem. 4 times 7 is 28, carry 2. 4 times 6 is 24, plus 2 is 26, so we know that that 6 was correct. Carry 2. 4 times 2 is 8, plus 2 more is going to give us 10 here. Carry 1. We now have solved for u, and we can put 0 for u. Every place that we have a u, and I believe that's it. Where can we go next from here? Look, let's go back up to the top. We borrowed back over here on this second or third subtraction problem. Remember, we borrowed from the tens column. We now know that that's 9, making it 8 because we had to borrow 1. 8 minus 3 will give us 5 for h. And now we're getting to the very, very end of the problem here. Let's go back down to this multiplication problem. 2 times 7 is 14, carry 1. 6 times 2 is 12, plus 1 is 13, carry 1. 2 times 2 is 4, plus 1 is 2 times 2 is 4, plus the 1 gives us 5. And then 2 times what will give us 2 down here at the bottom? Well, clearly that's going to have to be 1. So n equals 1. I missed an m there. I knew that I would miss one eventually. H, I missed that H there. And m is 3. A, yes, we solved for A. All right, so we filled everything in, and then if it pleases you, you can just go back through to make sure the math works on all of them. For example, in the first subtraction problem, 6 minus 2 is 4, 3 minus 0 is 3, 81 minus 76 is 5. So you can go back through and check all of those, but that's basically how you're going to solve it. Now that we have all of the letters represented by the numbers, we can go back to our original chart here, our original sheet, and fill those in and see what the answer to our problem is. 0 was u, 1 was n, 2 was e, 3 was m, 4 was p, 5 was h, 6 was a, 7 was T, 8 was I, and 9 was C. It spells out the word unemphatic, which is not a word I use on a daily basis, but there you go. You could solve this doing it as a straight anagram, but that kind of defeats the whole purpose of the puzzle, which is to use the math to arrive at the answer. And again, you could then take all of those and substitute the numbers in, but you've basically done all of that math in this breakdown over here. So that's pretty much, it's the same thing regardless of what word math problem you're doing. You have to hunt for that first clue that's going to lead you to the second clue, and then you have to kind of just work through it and see where each of those subsequent clues move you to the next phase of the problem until you arrive at the solution. So I hope that's some help for you on this particular word math problem.